Ladies and gentlemen, from News Talk 580, WGNC, please welcome Austin Rhodes. Believe it or not, I did that myself. Hello, Evans and Augusta, how are you? What's really cool about this get-together is that based on your very presence here, we know we've got one of the smartest crowds ever. There are 4 concerts in other places tonight. We're smarter than all of them put together. And we know that. It is a distinct honor and privilege to bring out our guest tonight. I can tell you, having listened to 2 hours of Luis talking to, many interviewers, but Joe Rogan was the one that really was interesting more than anybody else. And for 2 hours of it, it's been an enlightening couple of days. If you have had the privilege of seeing him in person, you know what kind of treat you're in for. One little secret I'll tell you, I think he's allowed to mention this. When he's in a broadcast mode, when he's on the air, on the radio and television, he has a line that he is not supposed to cross. When he's speaking one-on-one, he gets to step over the line a little bit. So listen carefully, you never know what you might hear. I will ask you this evening not to have your cell phones out. You don't want to be making calls or anything like that. It'd be very, it's rude, so don't do that. And, wait a minute. This is embarrassing. Yes, we have one about to bring her out. Okay, thank you. No more cell phones. Ladies and gentlemen, Luis Elizondo.
Hi, everybody. So feel free to come on down there. You walk back there, come on down there. Let's make this nice and cozy. We're all family here. I would like to thank Austin Rhodes, first of all, for that very much undeserved introduction to me. I appreciate it. He is a legend here, and very much appreciated that he would even show up to this. And I'm also honored you all are here. Please come on down. Let's get close. Let's get cozy. All right. So first of all, I don't know if you know this about me. I used to live here. About 25 years ago, my wife and I bought our very first home together here. And just right down the road, a little subdivision called Kingston Subdivision, right off of Wrightsboro Road. And this place has always been one of my most favorite places I have ever lived. And I mean it sincerely. To the point where I actually visited my old house 2 days ago, and I actually asked the current owner if he'd be willing to sell back my house. I really enjoy this place. I love the people, and Augusta will always have a very special place in my heart. It was during a very difficult time too. Spent some time in Afghanistan and Iraq, but when I came back, this was my sanctuary. This was my reprieve. And I remember everybody being always so friendly. Leaving Washington D.C. and having to come here, it was really wonderful, and it's memories that I will always have, my children will always have, my wife will always have. So hopefully soon, we're going to be neighbors again. With that said, I'd like to thank everybody and thank Evans Performing Arts Center and the staff, the amazing staff here for putting this together for us. It is truly an honor and privilege. So if you get a chance just when you're walking out, give them a little thanks, maybe shake their hand. And then, secondly, this presentation is going to be very interactive. It involves each and every one of you. So yes, I'm going to pick on you once in a while. I might even embarrass you, but that's okay because I embarrass myself all the time. But it'll be a good embarrassment. What I want to do is, first of all, before we start, see a show of hands of anybody who is either current or former military. Raise your hands, please. Don't put them down. Leave them up. Leave them up. Secondly, I want to know if anybody in here is either current or former law enforcement. Raise your hands. Raise them high. Don't put them down. Keep them up. I want to know if anybody here is a current or former first responder or nurse, paramedic. Keep them up. Keep them up. And last but certainly not least, I want to know if anybody is a current or former teacher. Raise your hands. Keep high. I want to thank you on behalf of the very grateful nation for what you do. I'd like to give a round of applause. All right, so following this presentation, we're going to open up to questions and answers. I will answer them as truthfully and forthcoming as I can. If I don't have an answer, I'll tell you that. Or if it requires an answer that we can't talk about, I will let you know that as well. But we'll do that, and afterwards, if anybody would like me to sign or a selfie, happy to take care of that as well. So let's get going. And by the way, you're here to talk about your favorite topic, UAPs, and we're going to talk a lot about that. A lot of stuff that hasn't necessarily come out yet in the open, so this should be a treat. But before we start that, I want to get you all to start thinking in a slightly different way about things. And it's important because when you're talking about something like UFOs or UAPs, we're dealing with something that requires us to think a little bit outside the box, not in the normal, traditional way. So, with no further ado, let's get going. See if we can get this little thing here to work. And of course, we can't. So there we go. Let's start back here. Try that again. I might have to do it manually. Let's try not to. Hold on. Let's do that. All right. So, what do all these people have in common? You just kind of saw a quick preview there. But think to yourself. See if we can get this together. There we go. Now, take a look at these folks. Right? These are individuals that are separated in some cases by thousands of miles, different continents, different parts of the world, different millennia, in fact, different races, different genders. What do these folks all have in common? Anybody? Oh, except the fact that they're all dead. I know, they're dead. Besides that. Yes, you're right, they're dead. That's right. That's right. They ushered in new paradigms. They challenged the status quo. Now, why is that important? Well, because a lot of us, we tend to kind of look at the motto of trusting the science. But that's not really how you do science, is it? You might be surprised to know there was a time that we used to prescribe in the medical field leeches as therapy for people who had anemia, right? Probably not very smart. There was a time we used to prescribe frontal lobotomies as a cure for depression, right? That didn't go so well. So, the advancement of society is always having the courage to challenge the status quo. That is how we innovate. Trusting the science is actually antithetical to actually doing real science. All right, let's try this again. I might have, okay. We now live in a time, this wondrous time, where we have technology available to us that we've never had before. This incredible technology called artificial intelligence, and we can leverage to help try to figure out what this is, what we're looking at. I can pose for your camera if you want. It's a it's amazing. And so we have the ability to apply artificial intelligence to this incredible phenomenon, this incredible enigma, like never before. And so that's exactly what we're starting to do. This is some of the benefits of AI. Now, what I'm going to do here in the next few slides, I'm going to share with you guys, I don't need to be screaming into the mic, forgive me. I'm going to share with you guys a real case study. This video you're about to see is a video that was taken, that was not supposed to be taken, so don't worry, I got you, I did the same thing. I'm going to show you a video that was taken by a military person on a U.S. military base out in California. He's a military officer in 2004, and he took a video of what he described as being an ominous black disc floating in the distance. So much so that he took out his personal cell phone camera and took a video on a restricted part of the military base. So, to protect his identity, I'm not going to say who he is, but let's look at this for a little bit. God, this does not have the range. There we go. Nope. That's right. I kind of gave it away, didn't I? This thing is terrible. That's right, anyways. It looks like a disc. Let's see the video. The compression's pretty bad on it, so I'm going to back it up so you can see it. See, you can see it for yourself. All right. Get it to play. No, anyways. This is a video with bad compression quality. When you see the still here, as I showed you here, that's what you see. This is important because if this were to get out in the wild, you can see how people go, wow, oh my gosh, there's a black UFO, just as described by this individual, by this Army officer. So what we decided to do is use artificial intelligence to go ahead and see if we could figure out what's going on here. By the way, if this doesn't work this last time, I'm going to have my friend here press the buttons for me to see if we can get this thing to go. But, Tucker, I think you're going to have to press something for me here because this is not working. Hold on one second first. Technical difficulty, but just pull out. All right, let's try this again, folks. We asked artificial intelligence, Tucker, do me a favor, press this button when I tell you to do the next slide, okay? And then we're going to just forget it. So what we did is we asked artificial intelligence to take a look at this movie and try to figure out what is in this actual video. Is it fake? Is it a hoax? So, go ahead, Tucker. So what happens is that the AI looks first of all at the background and notices some anomalies with the pixelation, some inconsistencies, that there are shapes in the background that are not consistent with the front. Now, the video is authentic, it has not been tampered with, but there is some shapes in the back, geometrically, that are not consistent with the shapes in the front. Secondly, it notices something that human eye can't pick up. It notices what appears to be some sort of landing gear or struts or some sort of protrusions emanating from the circumference of this black disc that he recorded in the desert. Right? So certainly looks pretty compelling. So we asked the AI, what are we seeing here? First of all, it detects with a 94% certainty the tail of a C-17 Globemaster cargo aircraft. Secondly, it detects the tail of an F-35 Joint Strike Fighter, a Lightning, and then what appears to be maybe two tails of an aircraft, two aircrafts crossing in the distance. So what we're looking at here, we can surmise, we're looking at an airfield, which is consistent with being in a military base. Makes sense, okay? Airfield, military base, something's going on here. Then we asked the AI to, with the best that it could do, by the way, 88% chance that there are protrusions emanating from this particular disk. So then we asked artificial intelligence, okay, with your best capability, what is your best assessment of this black flying saucer? That's right. It's not a flying saucer at all. It is a GP medium U.S. Army tent that's doing flight air operations observation with the size wall. That's all it is. Now, why is that important? Because when you're briefing members of Congress, because when you're talking to administration officials, you have to be 99% certain what you're looking at is authentic. Right? Now, this one wasn't fake, but especially in the days of now deepfake videos, our elected officials need accurate and precise information. And you can imagine that this picture before we had this analysis done, made its way out to Twitter and social media. For 30 years, people would be saying, see, I told you the U.S. Army and the military were doing secret recovery missions and reverse engineering of UFOs, right? We have to be our greatest critic. I know we all want to pursue the topic of UAPs and UFOs, but in doing so, we have to avoid the temptation where everything we see is a UFO. Because chances are most of what we see actually has a prosaic explanation. It is not indeed a UFO. But some are. So we have to be our own worst critic. Okay? So let's do a little bit of a thought experiment here. Thinking outside the box. Now remember I said we have to really kind of retrain ourselves to think in ways that we're not normally used to thinking. If we really want to tackle a topic that we're not normally used to talking about. So with that said, let's do a little practical exercise. What I'd like you all to do is very quietly to yourself, take the next 5-6 seconds. Well, Tuck, we went again too far. Let's go back. Name a type of ship, right? I don't know what the hell is going on. I want you to do your favorite, name a type of ship. But actually, it's going to work to my favorite, so watch this. Okay? So right now, so go to the next one. Right? Now, how many of you thought of this, a cruise ship or a boat, right? How many? Give yourself a D. Okay? Next slide. How many of you thought of this? A dirigible, an airship, like a Zeppelin or a blimp, right? Anybody? Hopefully you're learning a lesson here. Give yourself a C-. Tucker. How many of you thought of this? Rocket ship, spaceship, right? A space shuttle, Starship Enterprise. Give yourself a C. How many of you thought of that? I didn't say what type of ship, did I? I did not. Now I know I kind of cheated because I showed you a picture of the ship and I was like, oh, ship. The point to this little exercise is that we really have to broaden our understanding and our thought processes on things that seem familiar to us, but in the end really may not be very familiar at all. Okay? So UAPs and societal stigma. Let's talk about this for a little bit. We all know that stigma and taboo has been the #1 challenge to having a rational conversation about UAP. Why is that? When you have a conversation about UFOs or UAPs, the first thing that comes to mind, most people's minds are the tinfoil hats, all this on the mothership, all sorts of nonsense, right? That's because of stigma and taboo, and also the idea of pre-socialization of an idea, where even the very thought of it becomes untenable, unspeakable. So let's talk about that, for example, before we actually get into UFOs itself. Let's talk about this. The word para. Para is a prefix. We use it in the English language all the time. And in Latin, it's a Latin-based word. It means above or beside. So, when I say the word parachute, what do you think of? Well, for those of you like me that was in the military, you think of something that deploys over your head after jumping out of an airplane and hopefully helps you hit the ground with a thump and not a thump, right? And you think of something like that. Parachute, right? Nothing bad. How about the word paramedic? Right, the first responders in this room and the paramedics, something that's good, a medical professional first responder that's above or beside you, performing life-saving duties, right? And typically we think of that. Something good. How about this word? This good. Some of you just go, right? Something that kind of look at you a little funny, crook your head, maybe smile a little awkwardly. What do you mean, paranormal? I mean paranormal. And the reason why it's a problem is because of that. That's what we think of. However, I submit to you, the reality is everything in science is paranormal until it becomes normal. The cell phones that you use, the very laptops that you use every day, 40 years ago, absolute paranormal. Wi-Fi, G5, G4, GPS, absolutely paranormal until it just becomes normal. All paranormal really means is beyond our ability to understand at that time. Okay. Let's go over a little brief history of concepts in the past that were once considered paranormal to kind of drive my point home. Solar eclipses. The minds were able to predict it with such accuracy that most people thought it was magic. Right? Solar eclipses. Photography. This gentleman standing here, part of the Yanomami tribe in the rainforest, certainly not a happy camper. There was a belief that you were stealing your soul if you were to take a photograph. They did not understand the concept of photography. Would you believe that when I was at the University of Miami in the medical program, they were studying microbiology and immunology, I had a professor that had the audacity to tell me that acupuncture is Eastern medicine and it's not real, it's fake. It's psychosomatic and it's really some sort of magical practice that doesn't work. Would you believe that now at the Department of Veterans Affairs, we actually prescribe acupuncture for pain management for some of our veterans who are coming back from military deployments? It is not paranormal. It's science. It's neuroscience, folks. The men who hypnotize chickens. It's tonic and nobility. It's not paranormal, it's biology. In fact, if any of you are scuba divers, you know when you take a shark, flip it over on its back, it goes catatonic. Anybody who's ever seen an alligator in Florida or Georgia, there's alligator wrestlers, when you flip on its back, they go catatonic. It's a neurological function, a biological function, that is certainly not paranormal. In fact, it is natural. Now, we talked a little bit about concepts that have been labeled paranormal. The UFO topic has been labeled for many years as being paranormal. Or are we just talking about something that lies beyond our ability to truly understand? Let me offer you this. We live in a wondrous universe. There was a time where we thought we figured everything out. Newton comes up and says gravity is a result of an apple falling from a tree. You can measure it, and you can actually predict it. Force equals mass times acceleration and whatnot. And this was a wonderful revelation for mankind. And then some crazy cat with hair up to here named Einstein actually proposes something even more profound. He says, look, the universe is far more complex. In fact, the universe is where space itself and time are inextricably tied. In fact, you cannot have one without the other, and that space and time is both compressible and stretchable. Meaning space-time itself can stretch, and it's also relative. And if that wasn't profound enough, in the 1930s, the notion of quantum mechanics is proposed, proving you actually can be in two places at once. Doesn't make sense. And yet, that's what quantum mechanics has shown us. These are revelations, only in the last century or two, that have completely uprooted our current understanding of things. We're always learning new things. Let's take the 5 fundamental senses by which we judge our environment. There's only 5. And most of us, if you can't touch it, taste it, hear it, smell it, etc., it don't exist. It lies beyond our ability to perceive. But let's take optics, for example. Visible light spectrum. 0.0035% of the entire electromagnetic spectrum is this little tiny sliver we call visible light. And that is by which the way we judge the entire universe. 0.0035%. Which that means is that most of the universe lies beyond that spectrum and our ability to see it directly. Here's an example. This is a photograph between visible light and infrared. Infrared is just one tiny step down from the red spectrum, right at the very threshold of where we can see more. Look at the difference. In infrared, just one tiny sliver down, you begin to see nebulae, you see stars, you see things that the human eye can't perceive, and yet that's where most of reality lies. It lies beyond our ability to see. And if that's not mind-bending enough, now we have an issue of scale. We as human beings are this infinitesimally small speck hurling around some little obscure ball, around some obscure little star, around some obscure little part of an obscure little galaxy among many, many other galaxies. I'd like to show you a picture here. Anybody know what the pale blue dot is? That's right. This is a selfie. This is a picture by the Voyager when it started getting towards the end of our solar system. We asked it to turn around and take a picture of home. Every person you ever knew, every story that was ever told, every person that ever lived, every person that ever died, every war that was ever fought, and every war that was ever lost, every hope, every dream occurred on that little tiny dot. That is Earth, 2 pixels large, floating in the vastness of space. Here's another shot from the rings of Saturn. Right? We really are minuscule. We are tiny to the vastness of the space. And how big is the vastness of space? Oh, and by the way, if you were to actually take a telescope now and look at the farthest parts of space where appears to be a void, blackness, nothing is there at all, what do we see? Those are galaxies, folks, not stars, with hundreds of billions of stars in each room. The size of the universe is enormous. It's almost incalculable. This is a really interesting factor. Now, I don't know what a sextillion is, but it's a lot of zeros, right? So to put this into perspective, there are more stars in our visible, and foot stopping invisible, because we're going to talk about the rest of it, the visible universe, then there are grains of sand in all the beaches in all the world. Okay? That's how many stars are in the visible universe. No, going too far, go back. There we go. No, where you going, brother? There we go. Now, this is only less than 10% of the actual size of the universe. Most astrophysicists agree that most of the universe is bigger than much bigger, 10 times bigger at least. Now, why can't we see the starlight from the stars? Because the universe is so vast and so big and expanding so fast that light leaving those stars will never reach Earth. So, just how big is our universe? That's a lot of zeros. That's a lot of zeros, right? So if that doesn't humble you, let me give you something else here. As above, so below. How many of you took chemistry in high school? Maybe you chemistry teacher. Right. I actually liked my teacher. He was pretty good. I didn't like the class, but I liked him. Any of you remember Avogadro's number? 6.022 times 10 to the negative 23rd. That's roughly the same order of magnitude as the size of the universe, meaning a single hydrogen atom, 1 mole, one hydrogen atom, 1 proton, 1 neutron, 1 electron, is that small compared to the human body. In essence, that hydrogen atom is to us in size as we are to the universe. And that's inside every one of us. And we as human beings can only interact with 1 or 2 orders of degree magnitude up or down. Otherwise, simply the world, the universe is either too big or too small. We'll never be able to interact with it. It's beyond our ability to interact and perceive, right? And so this should be very humbling because we sit as human beings right about the middle at the scale of the universe. Meaning most of the universe lies in spectrums either beyond our ability to perceive, or frankly, it's too big or too small for us to perceive. So that's where most of the universe is. We judge everything through this little tiny itty bitty sliver. Imagine trying to judge the universe looking through a keyhole or looking through a straw, right? It's an impossibility. So now what we're going to do, now kind of recalibrate your brains a little bit to think and maybe a little bit differently. Let's talk about what you came here to talk about. AATIP, the Advanced Aerospace Threat Identification Program. I'm going to show you some slides here that should help debunk some of the nonsense people read on social media. This is the result of some of your $22 million, not all of it. There was a lot more videos out there. These are the 3 videos, the famous videos that AATIP helped get released. By the way, to this day, the U.S. government acknowledges that they are real, they are authentic, and that they don't know what these are. They're performing in ways we don't quite yet understand. The FLIR, the Go Fast, and the gimbal videos. There's an Easter egg, by the way, in this slide for you. For those of you who have sharp vision. This is a contract focus. But if you pay attention and look in the back and you see kind of some fuzzy words, that's the actual U.S. government contract. And these words here you see here are the actual words in the U.S. government contract that you paid for. Were we looking at aircraft 40 years in the future? No, we weren't. That was never the case. If whoever tells you that, they don't know what they're talking about. Let me draw your attention here to the bullet here, to go 3 up. Investigate legitimacy of currently observed phenomena, not technology, phenomena. And that's in the government contract. We were not looking at airplanes, we were looking at that. And if you look up here, you can start to see human interface, human effects, biological effects. So we can talk a little bit about that. In intelligence, in order to determine if something is an outlier, if something is an anomaly, you first have to do a comparison and contrasting of known technologies. And then whatever those performance capabilities are, whatever lies beyond that, then you set that aside and say, okay, this is an outlier. This is something that is different, it's unique, it's special. And so we realized in AATIP that there were 5 performance observables, and there was 1 effect observable, making 6 total observables, 5 performance observables. The first one was Instantaneous Acceleration, the second was Hypersonic Velocity, the third one was Transmedium Travel, the fourth one was Low Observability, the fifth one was Anti-Gravity, and it's a bad word in science, but that's what it is, and we'll talk about that. And the sixth one is biological effects. We're going to talk about each and every one of those this evening. So, why are the observables important? Because if some country has this capability and we don't, there's a national security issue. And I'm going to explain to you this evening why the U.S. government is so interested and so curious about these capabilities. Let's look at this first one here. Instantaneous acceleration, the ability to change velocity very rapidly. Now, we express those forces as G-forces, equivalent to the gravitational force of Earth. To put that into comparison, the human being, human body, can withstand approximately 9 Gs for a very short period of time before we start having medical consequences. Things such as blackouts, redouts, and ultimately death. So that's why our pilots wear G suits, to counteract that, right? Now, if you want to compare that to some of our most, well, let's look at the, for example, one of our most highly maneuverable aircraft, manned aircraft that we have today. It's an older aircraft, it's an older platform. It's the General Dynamics F-16 Fighting Falcon. And at the unclassified level, this aircraft can pull between 17 and 18 Gs before you start having structural failure, meaning wings begin to snap off and the airframe begins to disintegrate around you. Now, are we talking about aircraft that can pull 18 and 19 Gs? No, we're talking about things that can pull 1,000, 2,000, and 3,000 G-forces. Well beyond the healthy limitations of anything biologically to withstand, and even from an engineering perspective. We don't know how to do that. And if you can do that, if you look to the right here, these are some of the advantages that we as a government can gain from that if we understood it. And so you can see here, if we can do that over our adversaries, that gives us a distinct advantage on the battlefield. Right? So there's a real national security imperative to figure this out. The next one, hypersonic velocity. What is hypersonics? It is technically those speeds that are 5 times or in excess of the speed of sound. So how fast is the speed of sound? Roughly 768 miles an hour at sea level, plus or minus depending on the barometric pressure. So 5 times that is hypersonics. Now, do we have hypersonic vehicles? Yes. You read in the newspaper about Putin's hypersonic missile development capabilities. In fact, we had hypersonic aircraft even going back to the late 1960s, believe it or not. Any of you ever heard of the Lockheed YF-12A SR-71, the Blackbird, right? Yeah, that's a sexy bird. That can fly about 3,200 miles an hour. But when the Blackbird wants to make a right-hand turn, it takes roughly half the state of Ohio to do it. Right? We're talking about objects that are flying not at 3,200 miles an hour, but at 10,000, 12,000, 13,000 miles an hour in a low atmosphere environment and can conduct immediate right-hand turns in 180-degree turns. We don't have that. And if we could do that, right? Rapid deployment, enemy evasion, we have the first strike capability. These are distinct, and by the way, I'm not warmongering here, I'm just telling you from a military perspective, right? Why this is important. Why does your country, why are we interested in this? It's not out of curiosity. That's a hell of an advantage to have over your adversary, right? The next one, low observability. Do we have low observable aircraft? In fact, we do. For example, the F-117 Night Fighter. We have the B-2 bomber. We have the Valkyrie. But those are just low observable from a radar perspective. You can still see it pretty easy, right? That's not what we're talking about. We're talking about vehicles, and even to the naked eye, you have pilots that will say, Lou, this just sounds crazy. My radar was coming back like it was being jammed. I really couldn't get a good beat on it, and when I looked at it with my own eyes, I don't know how to describe it. Didn't have wings, didn't have control surfaces, ailerons, rudders, hell, it didn't have a cockpit. And then it just disappeared, right? So if we have that capability on the battle space, that leads to reduced cross signature, survivability, and anonymity. You can get in, do things you want to do, and get out, and do things you're doing, right? So from an intelligence perspective, that's a heck of an advantage. Transmedium Travel. All that really is a fancy way of saying it has the ability to operate in multiple environments, or what we call domains. Able to operate in the sea, able to operate in the air. Now, do we have vehicles that are transmedium? Sure we do. A seaplane is a perfect example. A seaplane can fly, and a seaplane can also float. But let's face it, a seaplane is neither a really good boat nor a good plane. Now, why is that? Because the more domains, the more environments you want to operate in, the more you have to sacrifice on performance and design. There's a performance and design sacrifice every time. That's why the space shuttle looks like it does. You know, it's got wings, but it doesn't really fly. It kind of glides like a brick, comes down, and hopefully you can stick the landing the first time because there's no second chance. You know, it's not a really good plane. Because there's a design compromise. And that's why planes look like planes and rockets look like rockets, and a submarine looks like a submarine. They're operating in different areas, different ways. You need different technologies. And yet with the UAP, that's all we're seeing. We're seeing things that can operate in our space in the atmosphere, and even underwater without those associated performance or design compromises. How is that possible? And by the way, what advantages does it give us? Well, there you go. Target flexibility, strategic surprise, right? These are really, and again, let me be clear here. I'm not warmongering you. What I'm trying to tell you is that this is why the U.S. government, from a national security perspective, is so interested in the UAP, because there's a distinct advantage over your adversaries if you can replicate this. And God forbid some other country does this before we do, like North Korea, right? So this is why you have the generals so interested in this topic. Next one. The battery, anti-gravity. Well, there's only 3 ways we, as humans, know how to defy Earth's gravity. One is through flight. Okay, what is flight? Well, there's 4 fundamental forces you have to accommodate for: thrust, lift, drag, and weight. And when you understand that, you can create wings, create a lifting body, and you can fly. And that's what we do. We take 737 to Palm Beach, right? You're flying to a location. The other way to defy Earth's gravity is through buoyancy. Think of a hot air balloon, think of a Mylar helium balloon. You have this cavity where the internal space is less dense than the external space, and it will rise to a point of equilibrium. That's what a balloon is. And then really the last way we know how to defy Earth's gravity is through sheer ballistics. Force equals mass times acceleration. If I put enough energy behind something, I can throw it up until eventually it comes back down to Earth. Just like a baseball. When I throw a baseball, same, that's ballistics. An ICBM, an intercontinental ballistic missile. If I put enough juice, enough power behind something, I can shoot it, blast it up out of a tube until eventually it comes down. Those are only the 3 ways we know how to do it. These things don't have any associated technology within them. They don't have wings, control surfaces, rudders, ailerons, elevators. They don't have any obvious signs of propulsion. No heat signature coming out the back. And in fact, they don't have even an acoustic signature. When you're flying hypersonics, there's no sonic boom, right? And if you can do that, if you have the ability to harness that type of technology, well, here's some of the advantages. You know, you can stay aloft a lot longer. You know, you can do things that your enemy can't do. Now, we're going to get into biological effects. These are just the performance effects, but I wanted to run this list down so you understand why the government is so interested in these observables, right? Because there is I think everybody would agree, if you're a military, you're a 3-star general, yeah, I want to do that too. You know, that makes sense. What else did your money pay for? Your $22 million. And by the way, there's more than that, because we dual source dual used a lot of money too in terms of our organization. Well, we had some of the best and brightest academics and scientists in the world. Let me say it again, in the world, not world according to Lou, in the world, do scientific studies on the physics required to do these 5 observables. And so what I'm going to show you is a laundry list here of some of those studies. Now, I'm not going to read all these out to you, but start looking at some of these, right? Biomaterials. What does that have to do with technology, right? Number 18, traversable wormholes, stargates, and negative energy. Did that sound like an aircraft to you? It wasn't. Right? We're talking about technology well beyond that. Number 25. Anybody know what the Drake equation is? See some heads nodding, some hands up. For those of you who don't know, it is the scientific calculation of the statistical likelihood of intelligent life in our cosmos. Why would the Department of Defense and the CIA be interested in that? You tell me. By the way, you can find these now online. I think even number 37 of these, almost classified, pretty classified. I think they have redacted some of that and released it. Okay. Cognitive limits. on simultaneous control of multiple unmanned spacecraft. So that's what some of your money was being spent on, right? Real studies on how these things are possible, how these UFOs are flying, what physics does it require to do that. And in 2015, I remember very, very clearly, I was in a skiff in the Pentagon, very busy by the way doing some work on counterterrorism, where some scientists came in and said, "Lou, you need to leave now, we need to talk to you." I said, "Oh, guys, I'm kind of busy." "Nope, gotta come out. This is very important." So I dropped what I was doing and went into a skiff. A skiff is a highly sensitive area where we talk about super classified stuff. And they spent about 3 hours doing a mathematical calculation on a whiteboard. Now, I was never very good at math. I got up to about Calc 3 and I thought I was going to die. I actually had to bribe my tutor. I had to bribe my teacher just to pass me. It was terrible. So we're not talking about math like that. We're talking much, much more advanced math than I could ever comprehend. So at the end, I looked at the scientists and I said, "I don't have a clue what you're doing. I don't know what that means." They said, "Look, what this formula means is that we have figured out all the observables are a manifestation, are a result of one technology. If you can do this one thing, if you can master this one thing, everything else you can do." Up until that time, we were spending millions of dollars trying to figure out the different exotic technologies required to replicate these performance observables. And it turned out that we were looking, like the song says, in all the wrong places, right? Looking for love in all the wrong places. It turns out that all this was a manifestation of a single technology. And so, what was that technology and how did it work? What was the physics? What was the soul of what was making these things fly the way they were flying? So, great. It had to do with gravity. What is gravity? A lot of us experience it every day, right? It's a law. But gravity might not be exactly what you think it is. You think of Newtonian physics, apple falling from a tree, oh, that's gravity. But it's not. That is an effect of gravity, not gravity. Gravity, as we now know through Einstein, is the warping of space-time in a localized region due to one of two factors. Anybody guess? Mass or energy? It turns out that Einstein had a really clever idea, E equals mc squared. Most people don't realize that energy and mass are actually coefficients of each other. You can switch them around in that equation, meaning you can warp space with a lot of mass or a hell of a lot of energy. And the question is, well, if that's the case, how do we look at mass and energy? Well, you can think of mass, if you ever have a glass of water, think of mass as ice cubes. It's hard, it's solid, it's tangible, you can tap on it, you can hold it. Think of energy as steam. Both are really, in essence, just water, but they're fundamentally two different states. And that's why when you take matter and you annihilate it, you get pure energy. And that's why when you take energy, you slow it down and condense it, you start getting subatomic particles. They're one and the same in a really kind of sneaky sort of way. So it turns out that the aha moment involved gravity. And so, my dear friend over here who has to keep pressing buttons, I'm sorry by the way, profoundly, but my click, I think it's batteries. It turns out that on Earth we experience gravity, one force of gravity is 9.8 meters per second squared, 9.8 meters per second, because the mass of Earth pulls us all down towards its center equally. Well, at least most of us equally, maybe probably more on me, but I gotta cut a few pounds. But the reality is that the mass of Earth is pulling us all down equally. So let's say you sir are a little more clever than me, which I'm sure you are actually. You have the ability to insulate yourself from Earth's gravity. You could create a bubble around yourself, say 43 feet. You had some sort of cool, super secret technology to create this bubble. We'll talk about it in a minute. And now all of a sudden, because of that, gravity doesn't affect, the warping of space-time doesn't affect you like it does the rest of us chickens out here, in the rest of the world. And so all sorts of neat things would happen. You could now fly without wings because gravity doesn't affect you, but something else happens, folks. The way, remember, space and time are connected. You can't have one without the other. If you insulate yourself from this bubble, from the effects of space-time, Earth's gravity, you're insulating yourself from the way you experience time itself. Now, I know that sounds weird, but time and space are being warped by mass. So if I was standing, for example, on Earth, I experience time and space a certain way. If I was standing, let's say, on Jupiter, it would be slightly different. Meaning the clock would run a little bit differently. The same thing if you got something supermassive like a black hole, where time and space actually get folded in on itself. But to put this in a more common terms, we learned this was real when we first started the GPS system that we all take for granted now in our cars and our watches and all that. I was part of the initial fielding of special operations back a long time ago, where we were testing GPS. And something really interesting happened during the early days. The way GPS works is you have a clock, like an atomic cesium clock at a ground station. And then you have these satellites or spacecraft that have the exact same atomic cesium clocks on board. And so, because of atomic decay, you should have their the atomic half-life. Those clocks are extremely accurate, meaning the times are precisely the same. And yet we noticed, after only a week, that we were having this thing called, this phenomenon called atomic drift. That the clocks on board the spacecraft were running at a different rate than the clocks on the ground station. Now, how is that possible? We spent millions and millions of dollars on these things, they're super calibrated, super specific, and yet the clocks were running at a different rate. It turned out, because the clock on the ground station here on Earth was closer to the surface of Earth, where the warping of space-time is more extreme. And in fact, if we did not calculate for this atomic drift after a couple weeks, if you wanted to go to New York, you'd wind up in Tulsa. That's how extreme. So we realized this. That was an example where we realized, oh my God, Einstein was right. And so if you had the ability to insulate yourself from Earth's gravity, by definition, you would also be insulating yourself from the way that Earth warps time. Meaning, your watch would be running at a different rate than all of our watches outside that bubble. So the question is, does that relate to UFOs and even their shape and the propulsion? Well, let's talk about that. So these are some of the morphologies, some of the shapes that people often describe as UFOs. You have the discs, you have the rods, right, like cigars. You have the triangles. Some triangles are bigger than others. And in some cases, very rarely, you have these humongous, reported being up to a mile long, boomerangs. These shapes seem so different from one another. Are they using the same type of technology to do what they're doing? Well, let's talk about that. So we talk about the bubble. How do you create one of these bubbles? Well, you're not doing it with mass, because if you did it with mass, you have to have a mass equivalent to that of Earth, and you would wind up perturbing everything on this planet. So the scientists assume correctly that they're probably using some sort of energy. And that energy is very, very, very energetic. And it so happens that if the energy can interact with the skin of the craft in a certain way, maybe a certain material, maybe bismuth and magnesium, something weird happens. You can actually potentially insulate yourself, create this bubble around you. The question is, what type of energy source would it take? And what do you mean interacting with the skin of the craft? You know, we all drive cars, you have an engine under the hood, and you got the car, and the engine kind of pulls apart. This is a little different. Imagine if your car, the engine itself was part of the body of the car itself. And it wasn't really an engine inside the car. You had some sort of energy source, and that energy source would interact with the skin of the car, the body of the car, and create this bubble. So here's our energy source, and if you see here to the right, the Alcubierre drive. Let me ask you all a question. For those of you who took maybe like geometry in school, if I wanted to create a vehicle that sat within this bubble and would be protected 360 degrees all around in a bubble, right? What's the only shape in geometry that would ensure that? Because by the way, you don't want part of your ship or part of yourself outside the bubble and part of you inside the bubble, because bad things happen. That term, it's really bad things, right? So what's the only shape? Then think of a diving bell. I want to be covered 360 degrees. What's the only shape? Anybody? Sphere. That's right. Well, the problem with the sphere is that, you put one on the ground and it goes around. But there's a shortcut. If I take a sphere and I squash it, what is that? It's a disc. It's a disc. That's right. It's still protected 360 degrees all around, equally. And so you have this disc. Now the problem is, this bubble's only so big. You can only fit so much. And it may explain why the discs tend to be smaller vehicles. Maybe fit 3 or 4 people, right? If this was a car, I could fit my family, maybe my 2 kids and my spouse in there. But I'm limited. So, before I continue, there's an old saying in the Navy: how many nuclear reactors do you put on a ship? And the answer is as few as possible. Because when something goes wrong, it goes really wrong, right? So, here's my family car, 43 feet, but guess what? Family's getting bigger. Now I've got kids, maybe a couple grandkids, sister-in-law, mother-in-law. So I need a bigger vehicle, right? I need a bigger vehicle. I need a bigger vehicle. So what can I do? Now that bubble is only so big. It can only be so big. So what I can do is I can put 2 of these discs together and interlock in bubbles, right? But what is that? That's right, it's a cylinder. Good call. That's right, it's a cigar. You put a power problem, you put a propulsion unit, one on each side, and now you've got your bubble big enough, and that may explain why some of these rods are described as being significantly bigger. Right? So if you look at this little scale here, our 6-foot guy now all of a sudden got a lot smaller because this is a lot bigger. This is a robust, maybe up to 80 or 120 feet. Right? But guess what? Now I've got the in-laws, and now I've got my wife's cousins, and my kids got their friends. I need a bigger bus. We're not all going to fit in this cigar. Well, the problem is I want to minimize the number of propulsion units while maximizing my space. Is there a shaping geometry that allows me to do that? How do I do that? Well, it turns out, think of Pythagorean theorem. Turns out I could go out directly at 90 degrees from the middle of this cigar. And what is that? Think of a 3-legged stool. Right now I've got bubbles protecting me still equally. Triangle, you got it. You've seen this before. It's triangle. Many of these reports on triangles, people see these bright lights at the apex of these triangles. Turns out these aren't lights at all. They've actually made the propulsion units. And what you are pursuing is what we call a Doppler redshift blue shift. Light in a different frequency, once it exits the bubble, is Doppler shifted into the visible light range. And that's what people are reporting. And these triangles are often reported as being large to very large. So if I didn't even get a bigger minivan, now I mean a school bus, right? These are huge. You often hear these really, really big triangles having a 4th light right in the middle. Probably the propulsion unit. That's what the scientists speculated. It is not light at all. It is part of a 4th propulsion unit that is creating these bubbles and protecting them equally while minimizing the number of propulsion propulsion units. But there's a problem, there's a challenge here, because economy of scale stops at this point. There are no other shapes in geometry that allow you to minimize the number of propulsion units while maximizing your real estate. So at that point, what do I do? Because I need like an aircraft carrier at this point. I need something huge. Turns out, the only option I have left is to daisy chain these things together. And what is that? It's a boomerang. And that's why these boomerangs are often described as having 9, 10, 11 lights associated with them on the bottom. Again, these are probably bubble makers. They're probably propulsion units. Okay? So here's our morphology. Here's a little 6-foot man on the left, the average size, which by the way, I am not 6 feet, but let's just say that's the average size. You've got your sports car, your disc, you've got your bigger rods, you've got your bigger triangles, your much bigger triangles, and then ultimately you have your huge boomerangs. And so it may very well be that these propulsions, these bubble makers, the number of bubble makers dictate the shape of the craft. So, we haven't talked about the Six Observables yet, which is it's a biological effect. It's not a performance observable. So, how does this same principle apply to biologics? Well, let's talk about that. Would you believe that the U.S. government has on its payroll medical doctors and scientists, and continues to pay them, to study individuals, U.S. military service member and intelligence personnel, who have come up close and personal with the UAP and have been injured? Your taxpayer dollars are paying for. Would you be surprised to know that there are individuals right now on full medical disability? Say that again. There are individuals right now that are on full medical disability paid for by